Now? Just say now. Okay, good evening. I'm Robert Holmberg. I'm one of the committee members of Science Outreach Athabasca, and we're not making much noise, I guess. So anyways, welcome to the first episode of our speaker series for this year. We have other speakers that we're tentatively getting lined up. And so if you look at our website, scienceoutreach.ab.ca, you will be able to see what speakers are going to be coming up in the next few months. So most of the people who attend our Science Outreach Athabasca events come from Athabasca area. And I wanted to get as many people speaking who came from the Athabasca area, and Allan tonight is one of those. He lives near Nanook. So tonight, Allan Lindoe is going to talk about fossils and behind the scenes, so about how to find fossils, how to collect them, and how to prepare them for exhibits. But Allan is raised in southern Alberta, and even in grade school, he was interested in fossils, and in high school, he found a fossil that he unearthed himself and prepared, and he'll show you a photograph of it. It's now on exhibit. And he, after high school, after working a few years doing other things, he became a technician in paleontology. And he worked at the University of Alberta from 1966 for about 30 years. And during that period of time, he collected fossils from Western Canada and the United States. And after he sort of semi-retired, he, because of his skills at doing things, he's now got about a dozen species, from mosses to mammals, that are named after him because of his ability to find fossils and prepare them. So when he sort of retired, he then got invited on a number of expeditions to Eurasia and Africa and South America, and was doing fossils then. But also, besides knowing a lot about fossils, Allan is an expert at wood turning, and he's also a fine photographer, and you'll see a lot of his photographs this evening. So we're going to have Allan give a talk, and then there'll be a question period after the talk. And if people have brought some specimens to look at, he will look at them and tell you what he knows about them. And then there's these exhibits here. And please, you can look at them, but please don't touch, because some of them are quite fragile. And we've got also some, if you want a fossil, there's a box of slices of petrified wood over there, and you can take them. Also, if you haven't already done so, if you put your name in the draw area there, we have 2 books and 2 models of fossils that are going to be draw prizes or door prizes. And other than that, I think I've got everything done. Take it away, Allan.
I'm going to talk about hands-on things and things that happen in the field and things like that. So this is the introductory picture, just a nice picture of Dinosaur Park early in the morning one day. We're not advancing. Oh, there, that advanced.
Well, try. He doesn't want to use the mouse, so okay. Try this. The space bar doesn't work.
No, I used this and that did advance. So
okay. All right.
Okay, to begin with, I'm going to just quick overview of what will be included in the talk. This view is from partway up a mountain in the Mackenzie Mountains. This is a fossiliferous area of Devonian age. So the first section will be what is a fossil? And there'll be a lot of examples. A lot of them will be Moroccan tourist displays that the Arab fossil dealers have. So, and then we'll go through some of the sites, this being one of them, and explain some of the difficulties with what they are. Collecting usually requires a whole bunch of, or not a whole bunch, but very specific techniques. So each area that we collect in requires fine tuning of how you collect. And a lot of them are examples here of things that get split out, and you'll see more about that later. And then after the things are prepared, there'll be a little bit on what happens. So first, what is a fossil? This next one is a very nice small pterosaur. It has a wingspan of about 4 feet. This is from Lebanon. And it's found in a building quarry site. And I'll talk more about building quarries later. It came in a whole lot of pieces, so I had to put the pieces together. Some of the bones were in, and it was a split specimen, so some of the bones were on one side and some of them were on the other. I glued them together and prepared the rock away, and you end up with a gorgeous specimen. And again, we're not advancing.
Maybe just hit it a little harder.
No?
I'll try the space bar. Oh, it went too far.
Okay, yeah.
Now I'll try the up arrow.
There. This is another specimen. This one is from platy limestone in Croatia on the island of Var. The larger circle circles the head, and the smaller circle circles the tail area. And between them, you may see a faint line of where the vertebrae were. Most of the bones of this are gone. It's not uncommon to find things like that. These are microscopic. It says it's microscopic. These are scanning electron photomicrographs of these diatoms and other marine animals. Some of them are gorgeous, and I like the aesthetics of a lot of these things. And there's just really nice. Some of the fossils are impressions. These are ginkgo leaves. You see the insert of a present-day ginkgo tree, and they're essentially unchanged. Those will be anywhere from Cretaceous to Eocene, so that's from 60 to present day, 60 million years ago to present day. These are more leaves. Those all look like relatively local leaves. Alberta. That's a cone of a metasequoia, so that's a redwood relative. It's in cross section. These are trilobites from Morocco. These have been prepared by a process of sandblasting, very miniature sandblaster. And if you know what you're looking at, you can see that the surface has been sandblasted. I don't like that process, but I don't know of another way to get those fine details on these fine spines. It's amazing preparation. These were prepared by a Moroccan guy. This is a fossil scorpion. It's from, is that Wyoming? Colorado. Yeah, so it's Green River Formation in Colorado. There are lots of things from the Green River Formation. Fish are most common, but there have been flowers, turtles, a bat, many different things. So Eocene is about 40 million years old. Insects trapped in amber are considered fossils. The amber itself is fossilized tree resin. And also used as jewelry. Oh, I think I know what I'm doing. I'm touching this pad.
Touchpad.
Yeah. So, and it's gone to Science Outreach and GP.
Oh, we have a,
Yeah.
oh, I have no idea what's
Yeah.
Kelsey or,
So I'm really good with my hands and I'm technically skilled there, but this stuff is a complete mystery to me.
I don't know where we
Do
are.
I just go back to the line?
I'm not sure.
Okay.
I wonder if the space bar will still work. No. Let's go back to.
Well, there we go.
It's relatively standard computer operation under my hands.
I can stay away from the top.
That's I will. Okay, so there are other types of insects or other preservations of insects. Uh-oh, touch bar, no, I did down arrow.
Is it not? Yeah, see, but that's the scroll wheel on this thing.
Okay,
It's for whatever
Hard to
reason.
with the scroll wheel though.
It is.
yeah, it's too fine. There, that went.
Yeah, now it goes.
Okay. Good.
Yeah.
So these are these are fossil flies from a site. Actually, we get these in a number of sites in BC. And the collecting procedure for that is to just go there and split rocks and split rocks and split rocks. Sometimes you find stuff. So this is an example of a water strider, you know, the long, thin things that skitter across the surface of the lake. Well, this is one of those things preserved. And you see that it is split and you get bits of it on both sides of the rock. This is another split specimen. This is a fish, mainly it's the head. This one was in the platy limestone of Croatia. This is a German crustacean. The brown one is the way it normally looks, and the blue one is when it's shone with an ultraviolet light, so it fluoresces. The actual fossil of the shell fluoresces a different color. Sometimes that can be used in preparation. I haven't used it, so. a local ammonite found in our river valley here with a little drawing of what or a painting of what an ammonite is. There's another one that's a little bit bigger. And in Morocco, there's a weird looking one. In the Mackenzie Mountains, the first scene after Dinosaur Park was the Mackenzie Mountains. These are the kind of things that we find there. This is just a mass jumble of bones of acanthodians, very, very primitive fish. This is one slab of a rock, and as I was preparing it, I found that the other side of it was also had specimens on it. So this is two sides of the same slab. The slab is about 1/4 of an inch thick. And these are Devonian fish. They're 430 million years old or something like that. The site is amazing. It isn't only bony stuff that gets preserved. A ray is a cartilaginous fish. So you see all of the fin rays and things like that. Everything can be preserved. This is one of those Moroccan display things. Bunch of shark teeth and a shark vertebra. Wapiti Lake in BC, the whole area has some Triassic sediment there. These are both, oh no, I'm looking at two things. This is shark teeth from Wapiti Lake. And this is the body of a small shark from Wapiti Lake. You can see that there's not much shape preserved or anything like that. The main body outline is the denticles. So it's the little tooth-like things on the skin of a shark that are being preserved. This is the fin of one of those same sharks, probably not that same species. This one's, the fin spine is a couple of inches long, so it's quite a bit bigger than that previous specimen. A Wapiti Lake specimen here is a coelacanth. They were thought to be totally extinct until live ones were being dredged up from the deep sea of Madagascar. Albertonia is another fish that we find at Wapiti Lake. This picture was taken in the field, which is why there's grass there and it's all broken up and things like that. Bulbosautrania, another Wapiti Lake fish. Later, you will see that there is quite a size variation in these things. This particular one, I think, is about 18 inches long, medium size. Now we're going to Wyoming. This is a perch-like fish. It's called Priscacara. Don't need to remember that. This is much younger than those previous fish. It's about 40 million years. And that's a trout, but you can probably see that it's just a smear of color. It doesn't have much actual feature to it. And that's from BC. Other BC specimens do have some real features. So the bones are three-dimensional. The fish is not three-dimensional, but the bones are. all those lines in there represent time. They're called varves. This is an explanation of the varves. So the dark layers are winter, and then the other variations are spring, summer, and fall. And it's quite clear when you're going through the specimens which season it is that those things died in. These vertebra are plesiosaur vertebra. That's an illustration of a plesiosaur, one of those really long neck things. Those are found in the river valley here, just down on the river. This is a Washington State ichthyosaur, a really unusual find. We can tell that it's a female ichthyosaur because it has 3 young in it. So it would have been about to give birth when it died. The primitive camel from Wyoming. You don't normally think of camels of being originally in North America, but these are well, look at the scene, that'll be 36 million years or something like that old. This is a rhinoceros from the same locality. If you know the big badlands of North Dakota, these are the same beds. Cave bear was found in a scuba explored cave in Croatia. It's missing one of its major canines, so you don't see that. And here we have some local elephant type teeth. Mastodon was a primitive, relatively primitive sort of elephant. And a mammoth, those are quite famous from North America and Siberia. Now there's another display from Morocco. There's a mass layer, a whole bunch of trilobites just died. We don't know why for sure. Maybe the oxygen was depleted in the water or they got buried, don't know. These also is a layer, and we'll get back to these later. Whole is a fossil. And we've got somebody here. I don't think he's looking for fossils. Fossils can also explain some behavioral stuff. So this is a recent horseshoe crab put on some German fossil horseshoe crab tracks. And they've been able to follow trackways on some of the big slabs from those quarries and find the horseshoe crabs at the end of the trackway. This Moroccan specimen in the field, those are trilobite tracks. So both of those kinds of things will depict a certain amount of behavioral information. These are worm burrows. They look like splots of something disgusting. And these are ripple marks on a roadside in Morocco. Ripple marks they can be either water or sand. These ones are water. Okay, now we'll go to various sites of places, but first, this is sort of the graphic representation of animal to finding. And next is a geologic time scale. There's another one over on the far corner there. That one has life forms included in the specific ages. It'll be more interesting. Man on the Hill site in the Northwest Territories. That's where those small black fish came from, which is an absolutely amazing site. They come from up there. The year that I took this picture, we weren't mainly collecting from there. We're collecting from this side of the cirque. And that's our camp. Those little orange spots are our tent. That's where we normally camp if we're going to collect at that main site. And then you climb the 1,400 feet up to the site. This is Wapiti Lake area. Wapiti Lake is sort of a large arcing ridge that has a number of cirques in it. So glacial scrape outs with little ponds in the bottom. This is one of them. Most of the fossils are collected on talus slopes. So we just wander around on the talus slopes and pick them up. There's one down there that's marked. That's pretty well where it actually came from. That's not the usual way we find them, but we do sometimes. Field trip in Dinosaur Park with Phil and Eva. And this is west of Devon in one of the deep valleys there. We were looking for fossil footprints, dinosaur footprints. Didn't find anything that day, but there are footprints from there. Badlands of Argentina. There are early reptiles that come from there, and also dinosaurs. You'll see some of the dinosaurs later. This is a building quarry site in Croatia on the island of Var. And the quarry site is there because they use the rock for building buildings. Sometimes they find fish, reptiles, things like that in the rocks that they're splitting out. And that's field crew members splitting slabs off of the rock. It's very platy limestone in many cases, but you can see some thick layers in that picture, which is quite massive. It's full of fossils, but it's hard to distinguish, and they're not the kind of fossils that we were looking for that time. We were looking for reptiles. There are leaves. That's me doing the splitting. Just whack along the crack, gradually work it, and it opens up. Didn't find much on that field trip. This was one that was found previously, and it's right on the shore of the Adriatic, and it was being weathered away. So we were sent there to collect it. And that's the collecting process. We saw around the specimen itself and then chip the specimen out. You can see that in that, and that's chipping the specimen out. That block ended up being close to 100 pounds. We were hoping for thinner separation layers, but that didn't happen. This is Mongolia. Badlands of Mongolia, famous for dinosaurs. Approximately the same age as Alberta Badlands, totally different. Really very different Badlands. This is a sauropod quarry, and a little picture of a sauropod down below. So we're just collecting a few bones of it. It'd be an ongoing process. It would take probably years to collect that. This is our campsite. Now going into Morocco. Most of the stuff that I was familiar with in Morocco was trilobites. The guy I was being taken there by was a trilobite collector. So that's what we did. You see that little trench in the foreground? And there are some strips of different colors in the background. Those are all quarries that the locals mine. That's a pretty extensive quarry, so there must have been a lot of pretty good trilobites come from that. And there can be trilobites in those blocks. You have to see it before you go to the problem of preparing it. You don't just blast through a rock and hope to find something. It'd be a waste of time. This is a cliff. It's really quite a tall cliff. A number of layers of productivity in there. This is called Issamor. That was my favorite site in Morocco. And another view, you see along up just below the vertical part of the cliff, there are a couple layers of excavation. This is a totally different site. This is Cretaceous, so it's much more recent than the trilobite sites. They were getting shark teeth, sawfish teeth, some dinosaur teeth, things like that. And you don't always just find fossils. There's a herd of locusts. Okay, next, the preparation and casting. So I'll go through some of the steps of collecting. The first is to expose. This is a dinosaur quarry in Dinosaur Park. First is expose the bone. And I'm an advocate of exposing as little bone as you can, as long as you can tell where it's going. Some people like to almost totally prepare them in the field. That's dangerous to the bones. So you see it's exposed and trenches cut around, and these guys are mapping the locations of the bones so that they get an idea where the bones are after we get them back in the lab and they get studied. These people are cutting and rolling burlap. We use burlap to cover the blocks of bone, much like a broken arm. And for about the same reason, because the rock would disintegrate if we tried to transport it without some kind of special preparation. So here's plaster being applied to a block. You can see a 2x4 on there that's being used as extra stiffening, and it's being undercut. It's cut underneath the block, and the plaster is wrapped around underneath. Later, there'll be a tunnel dug through so that it can plaster both sides of the jacket together so that it doesn't flex and slough the rock out. Then it's turned over and completely jacketed all over. This is a storage area in Tyrrell. The two jackets in the foreground have been opened up, and you see jackets in the background not opened, and storage. Normally, when we were just a small crew at U of A, we were collecting in 1 year enough work for about 10 years. preparation takes a long time. This is our lab in the U of A. This is the lab at Tyrrell. They're much more outfitted for things like that. You can see the arms there are dust collection, and there are a lot of tools around. You see cables, there are a lot of pneumatic chisels, miniature jackhammers. There's one on the table over there. Okay, going back to Croatia, I am mixing silicone because we want to keep as much information about that specimen before collecting it in case the collecting doesn't go as expected. Our collecting did go as expected, so that wasn't a problem. The other one, the one that says fossil and peel, that's a block which was found in Calgary and is now in Tyrrell. I prepared the fish out, and the people studying it wanted to have peels of it because the peel is used as a study medium. And there's ammonium chloride dusted from a low angle on it to show the contours of the bone, and you can get a really clear idea as to what the bones are and what they look like and all that. So there are 4 peels on there. There are 4 fish. Then they wanted a cast of the majority of the rock. So I've, on the left-hand side, I've put silicone over the whole rock, and I put aluminum foil on top of the silicone and patted it down to make a good contact. After that, I'll put a jacket on that because the silicone won't hold its shape accurately without a jacket, a rigid jacket to hold it. The second picture shows that peel rolled up. This is a garbage bin down at Tyrrell. You'll see one of those casts over, one of those molds over there. So that's a mold that has silicone in there. You can barely see the silicone. And then it's held rigid by the fiberglass jacket, which has itself to be held together. And you have to be able to take it apart. So that's why it's got the flanges. Those lumps you see in there are called keyways. They are in the silicone and captured by the fiberglass so that the silicone doesn't change shape when it's in the mold. We'll take that mold apart and you'll see that it flops all over the place. This is part of the reconstruction of a Tyrannosaurid. I don't know if it was Tyrannosaurus or Albertosaurus. I suspect Albertosaurus. But these are casts. So they're things that have gone through the molding process and been taken out. They're being assembled. They have still a lot of reconstruction and touch-up to do on them before they get completely mounted. This is a Pachyrhinosaurus partial skeleton, and it shows the metal frame which is supporting the bones. This is a Tyrrell display, and I like it because it shows what actually happens there. So that's pretty well the last stage. That's a display. Part of the thing that happens is you get scientific information. So the animal shown here is a mosasaur. The plaster cast of the skull over there is a mosasaur. The ammonite to the left has dents in it. Those are probably tooth marks from the mosasaur. They have found very good matches of mosasaur skulls to the tooth marks. This is our little paleo museum in U of A. Robert alluded to this specimen. This is the one I found when I was in high school, and I more or less prepared it, and eventually was permitted to mount it in this display. It has been named after me. It's one of the ones that's named after me. A pterosaur that I found and collected in Kansas. This one's big. It will have a wingspan of 10 to 12 feet. Oh, we're going back to the Bulbausotrania. So these three items are the same species, but in different growth stages. The big one is fully 2 feet long. Trilobite display at U of A. So it shows different lineages of trilobites, and the colors in the background indicate different ages. This is Giganotosaurus from Argentina. A big tyrannosaurid. And right next to it is this sauropod. Notice the people in the picture. Sauropods were big. From studying modern reptiles, they're able to extrapolate the musculature and various other aspects of dinosaurs. And that's what this display is doing. U of A has quite a renowned paleo program. At one point, at least, it was third in the world. And this is part of the teaching collection, and this is just one lab session. It's a dinosaur lab session. There's a little diorama of fish from the Mackenzie Mountains. I made the models and cast them and made the diorama. Now we're going back to this will be Alberta or North Dakota specimens. There's a place in Canmore that does the cutting and polishing of those things. That's there. These are ammonites. This shows very clearly the sections, the chambers that the ammonites had in their shell. The ammonite lived strictly in the last chamber, which is not preserved in this because the shell didn't, it's an incomplete specimen. This is a Moroccan tourist thing. I think there's quite a bit of reconstruction occurring there. And I think there have been a number of specimens that have been amalgamated into this one piece. If you're buying Moroccan stuff, you've got to be really careful about them. However, this is a shark tooth display from Morocco. There's no doubts about that one. It's quite clear. You see that there are lots of different shark's teeth. So you can tell the different species of the sharks by the teeth. Also, crocodile skulls. quite large. That big one is 2.5 or 3 feet long. And in the background, you see all kinds of trilobites. Some of those places were kind of bewildering to go through. This is ammonite, our Alberta gemstone. It is the outside of an ammonite. Some of our specimens here have a little bit of that. Not a huge amount. You've probably seen sinks, bowls, and other things made of this material. This is the nautiloid mass death layer, which I mentioned earlier, and I said we'd be coming back to it. This is one that's been all carved and made pretty and things like that. I'm not so fond of that. I tend more toward the scientific stuff, and this is where they mine it. So those layers are solid, that kind of material. They drill it and use feather wedges. So that's 2 pieces of metal, and then they hammer wedges into between them, and they've got a whole row of them, and it just pops the rock off. And from there, they cut it up and make all the stuff. So that's pretty well my talk. If you have questions, good. First of all, I would like to thank Robert for making this presentation for me. They're my pictures and all that, but as you've seen, I don't have the technical skill for this. So, okay, that's
Thank
it.
you very much. And so we'll take some questions if you have them right now. Yeah, and if there are any people online, they can send in a question as well. If Linda will respond.
Also, we can go around, and as we go around, you can ask questions. I know a lot of them were answered before, but if you need more information, I'm happy to say what I know.
I guess I have one question. When you go to your excavation sites,
I missed that.
when you go to the excavation sites,
Yeah.
how long would you go away for, like to Morocco and Croatia? And was that with you? You mentioned Bill and Eva. Was that Curie? Okay.
So we do get to see what's there. And there are lots of, especially from our nice stories.
Any other questions from anybody?
Yeah, okay, so we'll start over here. This whole section is about casts and casting and some of the specimens that are shown here. This is the fiberglass jacket to mold. This is the silicone mold. So you see, it does need support, or you're not going to get an accurate representation of the original. This is a gang mold. So it's a mold of a whole bunch of them. And it's used for making multiple copies of one thing. So that could be for giveaway. Just at the time of the start of COVID, I was supposed to give this talk,
Mm.
and I was going to make a whole bunch of duplicates, and I would have given away these things as well as the fossil wood. This is one that's probably most people don't see. This is a sucker, a mold, and reproduction. These are various mammal jaws cast in epoxy. Some plaster, epoxy, epoxy, plaster. This is a digital printout of a pre-max of Tyrannosaurid dinosaur. So a pre-max is the bone just in front of your upper jaw. This is a partially prepared fish, and I use tools like this and these little needles in pin vices. A whole array of ammonites and various other nautiloids. This is some of that Moroccan stuff that I was talking about. And this also is a Moroccan thing. This is as well. I think that this one is a faked up composite weird thing. I don't recognize it as any particular animal, but it's supposed to look like something. Oh yeah, this one, yeah, this was found in the river valley here. So that's an ammonite that was found here. The beds that are in the river valley here are marine beds. Various shells. This one comes from Panoka. You look at it and it's got lots of shells in it. I intend eventually to cut it, much as has happened to this. This is a different locality. This will be Wyoming. This is a Eurypterid, which I found on Cornwallis Island, up in the northwest Arctic Islands. 3 of these are Moroccan trilobites and prepared by the Moroccans mainly for tourist trade. This is something that was found in Jasper, and I don't know where these ones came from. Over here, we have some leaves, some insects, some shells with little trilobites and things like that. These are fossil insects, and there's one under this scope. Leaves of metasequoia. So this is redwood. The one that's under the scope here is a fossil flower. Leaves, a couple of examples of fossil cones. This is a reptile quite similar to the one that I was sawing out in Croatia. After I was finishing that sawing out, the water in the background was the Aegean Sea. I just turned around and hopped in. A couple of Wyoming fish. These are herring. Shark's tooth. This is a medium, small megalodon shark's tooth. This is a tyrannosaurid tooth. You'll see that if you can, you'll see that it has sort of a saw edge on both faces there. This is a ceratopsian tooth. So related to triceratops and things like that. This is Campsosaur. So that's that long snouted animal that was in the case that I said I found when I was in high school. That's a tooth similar to that. These three pieces are crocodile armor, bits of turtle shell. I don't know what bone this is, but it's a bone. These two pieces are vertebra. This one has had most of the vertebra weathered away. This piece, it's fascinating stuff, not a fossil. These pretty patterns, they're not a fossil. So all of these are crystal growths in one form or another. So this grows between layers of sediment, and it's calcite crystals that kind of push the sediment apart, and it gradually makes those. That's a piece of coral. That one's kind of fragile. These are thin slices of coral. I don't know. You should be able to see rays and things like that as parts of the construction of the coral. I was thinking maybe I should have dyed it or something like that to see if I could bring out some of that. I'm not sure what this is. And this is a coral. This is called a horn coral because it kind of looks like a horn, but it's upside down in life. This is a bone from a Titanothere. So this will be from the Oligocene of Saskatchewan. And Titanothere is a very large extinct animal, sort of between rhinoceros and elephant. Okay, so if you have other questions, then
We have a question here in the back.
yes.
I was just curious about splitting rocks.
Mhm.
So we've done that and found the fossils that come apart like mirrored.
Yeah.
So does it make sense that the cracks would follow the layer of where the actual animal was?
That's right.
So
Usually the specimen is a zone of weakness.
I see another question in the front.
I like small reptiles, like the Campsosaur. Well, they can be down to normal turtle size, things like that. Yeah.
So, Alan, for people on a smaller budget, are there any good sites in the area here? I have heard rumors that Musket Creek has some. Can you tell us a
That
few?
could be. I haven't explored Muskeg Creek, but I would be more inclined to go to the river valley because where you see the black shales, that would be more likely where you get them. And you'll get cone and cone there almost for sure.
We have another question in the back.
I was just wondering if you could go into the story on how you found that fossil when you were in high school a little bit more. Was it like you were amateur fossil hunting, or was it a total accident?
Yes. It's probably evident that I was interested in fossils when I was young, and we did family outings. And we went to a ranch that was across the river from Dinosaur Park. And they dropped me off in a little set of badlands that was a bit separate. I was wandering around and I saw it. It was a hind foot just kind of sitting there on the ground. So The other hind foot and the tail were already washed away, but the rest of it was there. So when I mounted the thing, I had to reconstruct those missing parts.
Any other questions?
Like, can you see the fossil from afar?
Oh, almost always we have to be right close.
Oh.
In fact, for a lot of the fossils that I find, I'm crawling on my hands and knees with magnification. Unless it's split out specimens and then you're just sitting there splitting rock and
No.
sweating, splitting rock.
Okay. Okay.
Any
Yeah.
other questions?
The Megalon tooth. How big is the Megalon tooth it could go up to?
I've heard of them being 7 inches long. So twice this size. You don't want to find it in your swimming pool. No, I don't think so. But they are back in the movies. Exaggerated.
What are all the time? What are all the fossils times from? And stuff?
They've studied the rocks and done chemical surveys, and they use radioactive minerals, which when they're deposited begin to break down, and they break down at a known rate. So measuring this form of it to that form of it, they can tell how long it's gone. And there are different minerals that they use for different time periods. The chart up in the corner there will probably give you more information. Yes.
It's in Athabasca or the Alberta. Not the. It lived in Alberta.
Well, we've got lots and lots of things in Alberta, but the
Oh
one
yeah. How much does a Tyrannosaurus Rex weigh?
I don't know. Yeah, I don't know. That's not part of the information I have. Many of the books will probably have that. But is that a question there or a stretch?
I'll just check online to make sure we don't have any questions. We didn't have any last time we checked. And do we have any more questions in the audience? No, seeing none. Okay.
So on one other point, Alberta has laws that if you find a skeleton, you have to report it to an official repository so that they can come and collect it. So the people up in McMurray call Tyrrell regularly to collect things that they find in the tar sands. And some of them are spectacular.
No. I'd like to thank Allan for taking the time for doing this presentation. And I'll do the draw for the door prizes. Like anyone can wander around and take a look at the stuff that's on display.
Yep.
And feel free to help yourselves to snacks.